Welcome to the deep dive. Today we're tackling something absolutely fundamental, really, to how the digital world works: API management.
hmm
Think of APIs as, I guess, the invisible glue holding our modern online experiences together.
That's a good way to put it.
What started as just a way for systems to talk is now, well, it's powering everything: omnichannel shopping, mobile banking, you name it.
And this huge growth, this explosion of APIs everywhere, different architectures, different
Yeah.
solutions, it's created a real challenge. We often call it API sprawl.
Sprawl, right?
Yeah, imagine trying to keep track of hundreds, maybe thousands of these connections. You lose visibility, governance gets inconsistent, it slows down launching new stuff, and just, keeping the lights on becomes complex.
Exactly. It's like having this amazing toolkit, but the tools are just scattered everywhere, hard to find, hard to manage. So our mission today is to try and bring some order to that chaos. We're going to do a deep dive into solutions for managing this growing API landscape. We'll focus specifically on MuleSoft's API management capabilities and deploying Mule workloads on container platforms like OpenShift. That seems like a really strategic combo.
Absolutely. And to get the full picture, we've looked at quite a few sources, videos from MuleSoft itself, naturally, but also great insights from NJC Labs, the SE Ecosystem Synergy and Acceleration Team, Tech Lightning, and people like Pramod Padmanabhan. So it covers everything from the basics of API management right down to the nitty-gritty of deploying on OpenShift.
Okay, let's get into the core then. That MuleSoft API management video really stressed the need for, well, best practices and the right tools for the whole API lifecycle: design, deployment, management, the whole thing.
That's right. And MuleSoft's answer is the AnyPoint platform. The key piece here is the API manager. Think of it like your central control tower for APIs.
Mm.
It lets you set up clear contracts, define SLAs, service level agreements, and even group APIs together logically. Makes oversight much easier.
And I saw something mentioned about platform APIs. That sounded interesting, like a way to embed governance early on.
Precisely. Platform APIs let you weave policy management right into your CI/CD pipelines, your continuous integration, continuous delivery process.
Oh.
So imagine every time you build and deploy code, the rules, security checks, traffic limits, whatever, are automatically applied, baked right in. It leads to much more consistent, reliable APIs.
Makes sense. Now, actually enforcing those rules, that's the job of the API gateways, right? MuleSoft has a couple of options there.
Yes, they do. First up is AnyPoint Flex Gateway. What's really neat about Flex Gateway is its flexibility, as the name suggests.
Right.
It's designed for APIs that might not live inside the main AnyPoint platform. You get full control over where you put it: Linux, Docker, containers like Podman, or even Kubernetes platforms like OpenShift.
So you can put it anywhere.
Pretty much. And this is great for performance because you can place that gateway really close to your application, minimizing latency.
Okay, so if I have a critical API maybe running on its own infrastructure somewhere, Flex Gateway lets me manage and secure it without moving the whole app.
Exactly that. Gives you that targeted control. Then the other option is Mule Gateway. This is more of a, let's say, traditional managed gateway service. MuleSoft handles more of the infrastructure side, which can simplify things operationally for a lot of teams.
Got it. Different tools for different needs. Now, what if the standard policies aren't quite enough? I think you mentioned a policy development kit earlier.
Yes, the PDK. This is where things get really powerful. The Policy Development Kit lets you build your own custom policies for both Flex Gateway and Mule Gateway.
Oh, okay.
So you can tailor the management precisely to your specific needs. Maybe you have a unique security requirement or a complex routing rule.
So I'm not locked into just the out-of-the-box options. How does this PDK work? Is it complicated?
Well, it's essentially a plugin for the AnyPoint CLI, the command line interface. When you start a new policy project with it, it sets up a standard structure. There's a g.yaml file for metadata and user inputs, configuration settings for your policy.
Okay.
And the core logic, the actual policy behavior, you write that using Rust in a file called lib.rs.
Rust, interesting choice, known for performance, right?
Exactly. And what's also super useful is that it supports DataWeave, MuleSoft's data transformation language. So you can actually manipulate data payloads as part of your policy logic.
Wow, Rust and data weave in a custom policy. That sounds pretty powerful. You could build some really sophisticated high-performance policies that handle specific data transformations or security checks that maybe aren't covered by standard policies. That could be a real advantage.
Absolutely. And the PDK isn't just about writing the code. It comes with good testing tools, too. There's a playground feature that uses Docker locally.
Oh, nice.
Yeah, it lets you test your policy in isolation before you even think about deploying it. Plus, it supports integrated tests for automated QA pipelines.
Testing is vital, especially for custom security stuff. You don't want to roll out a leaky policy.
Definitely not.
What about help and sharing these custom policies once they're built?
Mulesoft provides pretty comprehensive docs and lots of code samples on GitHub for the PDK. Great starting point. Once you're happy with your policy, you run a make build command. This compiles your Rust code into WebAssembly, or WASM.
WASM.
Yeah, WebAssembly. It's this really compact, efficient, portable format. It means your custom policies run fast and consistently everywhere.
Smart. WASM makes sense for speed and portability. So how do I get my shiny new custom policy into AnyPoint platform to actually use it?
Use another command. Make publish. You can publish development versions first. They get tagged with dev automatically so everyone knows they're not final.
Okay.
Then when it's ready, you publish the release version. Once published, it just shows up in API Manager alongside all the built-in policies. You can apply it, manage versions, see where it's used, just like any other policy.
Okay, that paints a really clear picture of the API management tools and the power of the PDK. Let's switch gears a bit now and talk about running Mule applications, the actual workloads, on OpenShift. The big driver here seems to be flexibility, giving customers more control, right?
That's the core idea, exactly. The videos we looked at, like Mule workloads on OpenShift, really emphasize this. Customers want to run Mule wherever their OpenShift is. Could be on-prem, could be in any public cloud, basically. Keep it within their own trusted boundaries.
Right, freedom of choice for infrastructure, keeping things secure. Now, I keep hearing Runtime Fabric, or RTF. What role does RTF play here?
So Runtime Fabric, especially in this self-managed model, is Mulesoft's technology for running and managing Mule apps on Kubernetes.
Hmm.
And OpenShift is, a leading enterprise Kubernetes platform.
Okay.
A really key concept is the split between the management plane and the runtime plane.
Right.
The management plane, runtime manager, API manager, monitoring that stays in Mulesoft's Cloud Hub, managed by them. The runtime plane, where your Mule apps actually execute that part, is self-managed by the customer on their own Kubernetes infrastructure. In this case, OpenShift. People often call this BYOK, bring your own Kubernetes.
Got it. Mulesoft manages the controls. Customer manages the compute where the apps run. Which specific Kubernetes services does this BYOK model officially support?
The Runtime Fabric self-managed Kubernetes deployment model video listed AWS EKS, Google's GKE, and Azure AKS as the main supported managed services. OpenShift, while not listed exactly like those cloud provider services, is a certified Kubernetes distribution and definitely fully supported for RTF.
Okay. And architecturally, how do these Mule apps running on OpenShift fit into the Kubernetes cluster itself?
So within your OpenShift cluster, RTF deploys a set of its own services. These run across different nodes in the cluster. It's these RTF services that actually manage your containerized Mule applications. But crucially, those applications, even though they're running on your infrastructure, they still connect back securely to the Mulesoft Cloud Hub management, plain runtime manager for deploying, API manager for policies, AnyPoint monitoring for observability.
That really does sound like the best of both worlds. You get the runtime control, but still have that central cloud-based management. What about connecting out to databases or other systems?
Connectivity works pretty much as you'd expect. If your data sources are in the same data center as your OpenShift cluster, your Mule apps connect directly. If you're connecting to cloud services, you just need to make sure your OpenShift network allows outbound connections to those services.
Right, standard networking applies. Okay, motivation and architecture make sense. Let's talk practicalities. Installing and managing RTF on OpenShift, you said it's gotten easier.
Yes, definitely. The big thing here is the runtime fabric operator for OpenShift. This was highlighted in several videos, including the virtual Muleys #70 session. Operators in OpenShift are like automated experts for specific applications. They handle the complex setup and ongoing management.
So the RTF operator does the heavy lifting for getting RTF installed and running smoothly on OpenShift. What are the main steps involved then?
Based on the various meetup and overview videos, it generally breaks down like this. First, in your AnyPoint platform account, you create a new runtime fabric environment, and you specifically select OpenShift Container Platform.
Okay.
That gives you some activation data. You also need your Mule license file, which you'll need to encode in base64 format.
Activation data, base64 license. Got it. What's next on the OpenShift side?
On the OpenShift cluster itself, you'll usually use the command line tool. You create a dedicated namespace RTF is the common name, but it could be something else.
A namespace, right? Like a logical boundary.
Exactly. Then, inside that namespace, you create a pull secret. This is just credentials, so OpenShift can securely download the RTF container images from Mulesoft's registry.
Makes sense. And then comes the operator.
Yep. You go to the operator hub within the OpenShift console. It's like an app store for operators. Search for Runtime Fabric, find the operator, and install it into that RTF namespace you created. There might be different versions, maybe a certified one, so you pick the right one.
Operator installed in the namespace. How does RTF actually start running?
Once the operator is installed, you then create an instance of the Runtime Fabric within that same namespace. This is where you plug in that activation data from AnyPoint platform and your base 64 encoded license. The operator sees this new instance request and just takes over. It automatically creates all the necessary Kubernetes deployments, services, pods, everything needed to run the Runtime Fabric control plane components within your OpenShift cluster.
So the operator really orchestrates that whole RTF setup inside OpenShift. What about exposing the Mule apps running on RTF so external users or systems can reach them?
Good question. That's handled by OpenShift's ingress resource. You define an ingress object that tells OpenShift how to route incoming traffic based on host names or paths to the correct Mule application service running inside the RTF namespace. You typically start with a template and modify the host name to match your cluster's domain.
Right. The ingress acts like the front door or traffic cop.
Yeah.
So RTF is up and running. Ingress is configured. How do I deploy my actual Mule applications to it?
That part should feel very familiar if you've used Mulesoft before. In AnyPoint Runtime Manager, when you go to deploy an application, your new RTF on OpenShift instance will just appear as a deployment target option.
Oh, okay. So it's just another target in the list.
Exactly. You select it, go through the usual deployment steps, configure properties, and deploy.
Speaking of properties, can I still externalize configuration like database passwords and stuff?
Yes, absolutely. You externalize properties in your Mule app as usual. The RTF operator on OpenShift is smart enough to automatically create Kubernetes secrets for your sensitive properties and potentially config maps for non-sensitive ones within the namespace.
So it handles the secure storage in OpenShift.
Right. The videos did mention that the secrets integration is very solid, while the config map part might evolve further.
Okay. And finally, monitoring. How do I keep an eye on these apps running in RTF on OpenShift?
You get monitoring from two angles, which is great. First, AnyPoint monitoring works just like it does for other Mule deployments. You get all your Mule-specific metrics, logs, dashboards right there in the AnyPoint platform.
Okay, familiar territory.
But also, because it's running on OpenShift, you can use the OpenShift console itself to see container logs, pod metrics, resource usage, the infrastructure level view. So you get both the application perspective and the platform perspective.
Excellent. That dual view seems really valuable. Okay, let's pull back a bit. What are the big advantages people see when running Mule on OpenShift? Why go this route?
Well, flexibility is huge, as we mentioned. Run Mule anywhere. OpenShift runs on-prem, any cloud. True hybrid cloud, cloud agnostic, that came up a lot in the videos.
Right.
The simplified installation using the RTF operator is a major plus. It lowers the barrier significantly, and you're leveraging OpenShift's enterprise capability, security like RBAC, secret management, container orchestration. It's robust.
It feels like it creates a common ground, right? OpenShift for infrastructure, AnyPoint for the integration layer.
Exactly. A common control plane approach. It helps with modernization, makes workloads more portable. Plus, you get access to that whole OpenShift ecosystem of certified operators alongside Mulesoft's connectors. It's a powerful combination.
Lots of positives. But what about the other side? Any challenges, gotchas, things to be aware of?
Definitely some considerations mentioned, especially in the Meetup and Virtual Muleys talks. First, you need a decent understanding of OpenShift concepts like operators and namespaces. Making sure you install the operator instance in the right namespace is key. You can change the default RTF namespace name, but you need to be consistent everywhere if you do.
Okay. Any environment specifics?
They noted that CRC cluster-ready containers for local OpenShift dev can be pretty resource-hungry and maybe not ideal on Macs. Also, managing secrets needs careful thought. While OpenShift secrets work, the recommendation often leans towards using external stores like HashiCorp Vault, CyberArk, Azure Key Vault, or managing them via CI/CD for better cross-environment consistency and security posture.
Right. Treat secrets as a first-class concern. What about cost?
Cost is definitely a factor. You've got OpenShift licensing on top of your cloud infrastructure costs and your Mulesoft license. Managed OpenShift like RSA or ARO might offer bundled pricing, while self-managed OCP is more granular. You need to factor that in.
Makes sense. Any limitations in the current GA release we should know?
A couple of things. The current GA deploys RTF at the namespace level, meaning you need to pre-create those namespaces and set up necessary permissions beforehand. Also, things like horizontal pod autoscaling, HPA, and vertical pod autoscaling, VPA, aren't in the GA release yet, though they're apparently on the roadmap.
Okay, so autoscaling is coming, but not here today.
Right, and migrating from the older RTF appliance isn't a push-button affair. It requires planning back a press store, understanding that the OpenShift control plane replaces things like Ops Center and the old controller nodes.
And that namespace level deployment, that actually enhances security and resource management within a larger OpenShift cluster, right? Scoping RTF to specific teams or projects.
It does, yeah. It allows for better multi-tenancy and isolation within a shared cluster. It's a good design choice for enterprise environments.
Well, this has certainly been a thorough deep dive into Mulesoft API management and running Mule on OpenShift. It really seems like this combination offers a compelling path for organizations wanting that mix of flexibility, scalability, and strong security in a hybrid world.
Absolutely. And the aha moment for me, I think, is how the RTF operator really simplifies getting Mule onto OpenShift. It makes that integration much smoother. Plus, having that unified management view across AnyPoint and OpenShift is pretty powerful.
Agreed. For those listening, if you want to dig deeper, definitely check out the official MuleSoft and OpenShift documentation. And the GitHub repos for the PDK examples are worth exploring too.
Yeah. And it leaves us with a final thought for you, the listener. How could adopting a cloud-agnostic platform like OpenShift, paired with MuleSoft's integration power, really reshape how your organization builds and manages its digital experiences? What new doors might that open for innovation and breaking down those persistent data silos?
Something to think about. Thanks for joining us on the deep dive.